So let's take a look at just IP addressing and the way that this works. Once again, this is really just to make sure that everybody's on the same page. Okay, so if I've got 192.168.1.2.63 and a subnet mask of 255.255.255.0, then basically what we're saying is, you know, the first 3 octets of this number are being blocked. And so the network ID in that case would be 192.168.2.0. When you write the network ID, you're writing all zeros in the host portion. Okay, and so when the mask stops, I could do it over here. 63. When the mask stops on a decimal point, we don't really have to worry about it. What is 255 in binary? Well, it's all ones. Okay? So basically what we've got with this number well, apparently we're going to need to put the space there because it is acting like that's an expression. There we go. What we have with this number is we have all ones. So notice the mask is on. That's all ones. And so that means that the portions of the IP address that it's shielding, that's the network ID. The portion that it is not shielding, that's the host ID. Okay? So we've got that with every IP address. Let's get rid of all that. The numbers here can help you if you're trying to do simple binary to decimal or vice versa conversion. Okay, so let's say we've got a number in a mask, or we've got a number like that, okay? If you're trying to do binary to decimal conversion, all you're doing is counting the 1 values and not counting the 0 values. Now, first we should say and make sure we know how I came up with this. Binary is has a base of 2. It's a base 2 numbering system. That means there's only 2 possible values, 0 or 1. So your base number up here is 2, and you say 2 to the 0 power, that's 1. 2 to the first is 2. 2 squared is 4. 2 to the third is 8. On and on, to the 4th, to the 5th, to the 6th, to the 7th. There's 8 possible values in this 8-bit binary number. Okay? And so these numbers are simply the decimal equivalent of that particular place. And so when we have a binary number that's 8 bits, we just lay it out underneath this table, and if it's a 1, then we count the value. So we're saying 128 plus 64 plus 32 plus 16, and then we're not adding any of the rest. Okay, and so we could do a quick formula there, and that way this will work every time we do it. Okay, so let's get rid of these over here. All right, so if we're counting those values, then our value is 240. Okay, and so the same thing could happen as soon as we change the numbers. Just do another number, 1 0 0 1 1 0 1 1. We go to convert that. We got 128 0 0. We got 16 being counted. We got 8 being counted. We got 2, and we have 1. Okay, and that's a decimal value there of 155. All right, so you see how that works, and again, hopefully that might be review, but that's going to help us out here in a minute. Because if you get a number like this, 192.168.63.240, okay, and then the subnet mask is 255.255.224.0. Well, when you're trying to figure out what the network ID is, which may be important if you're trying to figure out a connectivity issue, you know that it's 192.168, and you know that it's .0 because we've stopped here, right? The 3rd octet or the 4th octet is not being used. But what is 224 of 63? And so it's in that scenario that you really have to you have to convert both of these numbers. This middle octet, this third octet has to be converted to figure out where's our line? Where does the line stop? Where does it signify that the subnet mask stops? So let's do 63 first. Okay, that's going to be 0, 0, and then it's going to just be 1 all the way up. Okay, I know that just because anytime you have a number like 63 that falls right before one of these numbers, it's all ones. So 32 plus 16 plus 8 plus 4 plus 2 plus 1 is 63. Okay, then we put the subnet mask of that's not right, of 224. 224 looks like that. This is 224 in binary. It's the 128 plus the 64 plus the 32. Okay, there we have 224 just to prove that, all right? So 224, so that means that my line here is stopping at the third bit. Okay, so it's only these first 3 bits that are the network ID. Now, technically what you would be doing is you'd be drawing a line, and everything to the right of it, part of the host ID, everything to the left of it is part of the network. Now, what we can actually do is a process of ANDing, where we combine these two numbers, and the only way the result is a 1 is if both values are a 1. So here we've got a 0 and a 1. The result is a 0. Sorry. Next one, we've got a 0 and a 1. Same thing. Result is a 0. I wish I would do it correctly. There we go. All right, 1 and a 1. That's the only one that's going to be 1. Now it's all turned to zeros, so the rest has to be 0. So what do we got? Well, we've got a 32. That's it. So the network ID of that IP address is 192.168.32.0. Now, once you get really good at binary and you can do it in your head, that was actually a fairly easy one because of the numbers and the way they fell. You could have probably come up with that. But I always say if you are able to come up with it, then the reason you are is because you're doing the binary in your head. It's not that you just looked at the number and said, oh yeah, that's got to be this, because it's impossible to do that. With a decimal number and a binary number, you can't just look at 224 and immediately know what the ID is. You have to do some sort of formula in your head or on paper. So I've just shown it to you on paper. Write out the subnet mask, 224, in that octet. Write out the number in that octet. When the ones stop in the mask, everything else is going to be a 0. Okay? So it matches, and then you can figure out the network ID. There is another one that's a little bit even easier, stops you from having to use the binary, just a quick trick so you don't have to spend a bunch of time if you're looking at an exam question. And that's that there's 256 possible values in a binary number, right? From 0 to 255. So there's 256 possible values. You take your number there of 224 and you go 256 minus 224. And the result of that is going to be 32, okay? So 32, and the reason that's important is I know that this is 192.168.0.0. That's your 255. And then we've gone a little bit further into that next octet. So the reason we figure out this number is because we could just start writing network IDs. The first one's going to be 32. The second one is going to be plus 32, 64. The third one, 96. And you could keep going. We don't have to keep going in this case because we've already seen 32 and 64, and we've got a number here that's 63. So it tells you what network it falls in, all right? Personally, I never minded the binary. Some people loathe binary, and so they want that quick formula. But this is going to be important that we understand it. Number one, you got to configure IP addresses correctly. Number two, you got to be able to look at an IP configuration and say, hey, wait a minute, that's not right because these systems are on the same network and they've got 2 different network IDs. Or this system's trying to get to the internet, but it has a gateway that's misconfigured. It's on a different network segment. Those kinds of things you'll be able to identify if you are able to read and understand IP address configurations. There are various ways in Windows 10 that we can configure network connectivity, just depending on what you want to do. There's the Network and Internet in the Settings app, which is probably the first place we're going to think of in Windows 10 at least. There is the Network and Sharing Center. This is kind of the carryover from really back in the Vista days. And Windows 7, Windows 8 have all had the Network and Sharing Center. It's a prime location to go and configure new connections, manage existing connections, manage wireless connections, all of that. And you do have Windows PowerShell as well. You have a number of different commandlets that are related to net interfaces, net IP addresses, DNS server addresses, all of those things. So, the one that you choose is really going to be dependent on the situation. Obviously, from a simplistic standpoint, using the Settings app Settings app in Windows 10 is going to be the best way of doing it. We also have manual configuration versus automatic. The vast majority of your organizations are probably going to be doing an automatic configuration. That is using DHCP, Dynamic Host Configuration Protocol, automatically assigns IP addresses to clients. When we're in wireless networks, always going to use this because we don't want to statically configure. But even on wired networks, we don't want to statically configure client machines. We want a machine to boot up, communicate with DHCP. DHCP gives it a usable address out of the scope or the range of addresses that it has to give out, and you're off and running. It's centrally managed, and it works very well because we can ensure that clients will always get a correct IP configuration. The problem with manual is that you can run into issues with incorrect configurations. You type one number wrong in the network ID and you're going to have communication problems. So the vast majority of times you're going to be dealing with an automatic configuration, and the primary concern there is that the DHCP server is available and that it has IP addresses to give. The first time you connect to a network in Windows 10, you'll be asked to identify the network, the type of network that you're connecting. And there's three types. There's home and work, which are both considered private networks. Then there's a public network, and then there is a domain network. Okay. Now, you'll never be asked to actually assign the domain network. If your computer's a member of the domain and connected to that network that contains that domain, it'll automatically associate itself as being the domain network profile. But you do choose whether it's home, work, or a public place, and then it brands that particular connection, wireless or wired, as being a part of that profile. And the configuration being remembered, being manageable, is important because it controls the behavior of applications. It controls the inbound and outbound rules in the firewall. Those rules are active for a particular profile. It also can control printers. You can configure printers based on network location. This is called location-aware printing. You simply set a default, and when you set a default, it remembers the network for which that printer was made the default. Okay, so it's pretty simple to do. I mean, it's the initial connection that you set it. If you do mess it up or you want to change the profile later, you can just go into the Network and Sharing Center and you can modify the profile of the network that you're currently connected to. So let's take a look at the network settings here. We're just going to go into the Settings app, and we have Network and Internet. Okay. This is data usage, so that's really meaningless to me. I can go to Ethernet, see that I'm connected, get the properties. That's very odd that it's not showing me any of those. Go back in there. Yeah, because that's weird. That's showing connection, but it's not actually showing me anything else. If I hit related settings, you're going to start jumping into other places. Network and Sharing Center, Internet options, advanced sharing settings. So let's actually we'll jump over to our other virtual machine because it's a little bit strange. Here we go, Ethernet. And when you select that, yep, that's more what I was expecting to see. I'm not exactly sure what's going on with the other one, but we see an IP address there. We see my DNS servers. I see the type of network adapter and driver version, the physical address, which is the MAC address. And that's really it. I mean, there's nothing much you're going to do in here. This is pretty basic, but it allows you to see it, and it allows you to get into, use that as a launch pad to get into the other areas, okay? So here is my domain. I'm connected to the domain network. I can change adapter settings and get into that configuration. Go to IPv4, we can assign an address automatically. I can assign a DNS server address. Okay, so those things can be configured there. You can also click on Ethernet there, hit details, and this is kind of the standard view as well. Of the properties of that connection. Okay? So you get different options there. So now let's open up Windows PowerShell. Take a look at some of the options that you've got in PowerShell. And those options are going to be in, let's see, get command, and then the module. Actually, let's go get module and list available. There are actually several here that we can access, and you might find PowerShell ISE is a little bit easier. But Net TCP/IP is probably your big one. You also have the Net Adapter and Net Connection. So Net Connection, Net Adapter, Net TCP/IP are the primary ones that you would be using. So if you go get command in module Net TCP/IP, then it's going to show you that in here we've got the ability to retrieve addresses. So get net IP address. Don't have to know the ins and the outs of these, but these are good to know. Get net IP address if you want to cut down on what it's showing you. That can be a good thing. So maybe I just care about interface alias, interface index, and then the actual address, right? Or the prefix. So you can run the same command and then just say pipe format table or format list. I'm going to go format table, and I only want to see the interface index, the interface alias, and the IP address. Okay? And so then it just shows you just those things, and you can even filter out and just view IPv4 if you want it. All right, so get net IP address is just a way to display it. The new net IP address command is the way to add an IP address. So I'm going to go help on the new net IP address, and we'll grab some examples just to show us. Okay. So new net IP address, the interface index, the IP address itself, the prefix length, and then the default gateway. Okay. And then there is a remove. So the first command adds it, and then the second command is going to remove it. But actually what the second command is doing is removing, well, no, I guess in this case they're removing the same one. Okay, so, but you're going to have an address. You would think that it would be set, but it's not. To create an address on an interface, it's going to be new net IP address, right? And if we go get net adapter, get net adapter, pipe format list, shows me all of the information. And this is basically the same kind of information that you had over in Network and Sharing Center or the Settings app. It's the interface itself, it's the index, it's the physical address, it's Ethernet, so its media type is 802.3. You know, those kinds of things. And I mean, there's more stuff here that we could go through. I mean, look at all those commands. We could view the routing table. We can view current connections. We can view protocol statistics. But a lot of that is just not overly necessary. So I want to show you just a couple of things so as to get you somewhat familiar with the PowerShell ways of doing things. So in Windows 10, we've got the network settings or network portion of the settings app. We've got the Network and Sharing Center, and then we've got Windows PowerShell. Those are all places that we can go to configure network connectivity. Of course, At this point, we've really just talked about IPv4. There's another protocol that we could be configuring as well.